Good morning, students. We are here for our online classes. We were doing chapter 3. We'll continue with the chapter. Today we are going to do the last topic of this chapter, that is the chapter the earth, the interior of the earth. We have already finished most of the part of the chapter. We have discussed about the different sources of evidences to know the earth's interior. We have discussed about the volcanic eruption, what are the different types of volcano. We have also discussed about the intrusive forms, what is earthquake, what are seismic waves, what is a shadow zone. Today we are going to discuss about the interior of earth, that is the structure of earth. If we talk about the structure of earth, your earth has a layered structure. It can be divided into basically 3 concentric layers, and these 3 concentric layers are divided into crust, mantle, and core. Now, to know the earth's interior or the structure of earth, we have already discussed the 2 phenomena which takes place, that is earthquake and we have also done volcano. Today we will study the structure of earth and we will see what is the relation between earthquake and volcano and the structure of the earth, how these 2 phenomena must have helped us to know the earth's interior. If we talk about the crust you can see the outermost layer of the earth. So if you draw the diagram, a cross section of earth, we see on the surface mountains as well as we see depressions which are filled up with water known as oceans. It means I am talking about, suppose if the features, this is your crust, which is the uppermost layer, it can be seen from here. Now this crust has been divided into 2 categories. The part where we see the continents is known as the continental crust, and the part where we see the oceans, this part of crust is known as oceanic crust. So the first thing you need to know, that crust has been divided into 2 categories. One is continental crust and one is oceanic crust. The second thing which you should know about the continental crust, you can see that the thickness of the continental crust and oceanic crust, if we compare, the thickness is more here near the continents and it is thin here near the oceanic crust. So the thickness of oceanic crust is 10 kilometers, whereas the average thickness of continental crust is 30 kilometers. So it means the layer which lies below the crust, that is the mantle layer. If you need to reach the mantle layer, it will be easy to drill the earth from the oceanic crust because you have to travel only 10 kilometers. So regarding crust, what you should know, crust is the topmost layer of the earth, that is the surface of the earth. It divides into 2 categories. The continental crust, which is basically we see the landforms on the surface, and one which is beneath the ocean is known as oceanic crust. The thickness of continental crust is 30 kilometers and the oceanic crust is 10 kilometers. Beside this, there is one more difference. You will find the continental crust is lighter. So it is also known as sial. The word sial is basically the constituents which makes up the continental crust, that is silica and aluminium. In the same way, the oceanic crust is denser than the continental crust. It is also known as sima, that is silica and magnesium. So this is the third thing regarding crust which you should know, that the continental crust is made up of lighter materials, that is, or lighter elements like silica and aluminium, whereas the oceanic crust is made up of denser elements like silica and magnesium. If we talk about the density of minerals, you will find its density is 2.8 grams per cubic centimeter. Whereas if you talk about the oceanic crust, the density is little more than that, that is 3 grams per cubic centimeter. So I hope it is clear regarding crust, what you should know regarding crust. If question comes, what are the features of crust, you need to write that crust is the uppermost layer of the earth, divided into two categories, continental crust and oceanic crust. Your continental crust is also known as sial. We can see the landforms which is made up of lighter elements, silica and aluminium. Your oceanic crust is little denser than the continental crust, made up of silica and magnesium. If we talk about the thickness, it is thinner than the continental crust. It extends 30 kilometers, whereas you can see it is only 10 kilometers. So it is easy to drill. We have discussed about the deep ocean drilling projects. Why they are done here? Because the thickness is only 10 kilometers. So it will be easy for them to drill the earth and to reach the mantle layer. So this was all about the crust. Next we go to the mantle layer. Now if we talk about the mantle layer, it is the most important layer. Mantle is also divided in the same way, two categories. One layer which is lying here in mantle is a weak zone, and this zone within the mantle is known as, we have discussed in our previous classes, asthenosphere. If we talk about the thickness of mantle layer, it is 2900 kilometers. We were talking about volcanoes in one of the topics when we were discussing about this chapter, why volcano has been associated with this structure of the earth. Now you have seen this is the layer asthenosphere which is present in mantle layer. This layer of asthenosphere is basically not a brittle or a solid layer, rather it is in semi-molten stage. Now because it is in semi-molten stage, it is ductile in nature. Ductile means it can be easily stretched and stressed. So because of this, whatever volcanic eruptions are there, which takes place on the surface of the earth, is because of this mantle layer. And because of this volcanic eruption, we come to know that there is one layer below the crust which is not solid in nature, rather it is semi-molten in nature, and this comes out during eruption. In the same way, there is one more importance of this mantle layer, is that we have talked about the eruption in the ocean floor when we were discussing our volcano, and we have done mid oceanic ridges. This volcanic eruption, when it takes beneath the ocean floor, it solidifies, forming here ridges. So again, that is why mantle layer is very important. It helps us to know the reason behind the formation of mid-oceanic ridges as well as seafloor spreading. The third importance of mantle, how mantle is so important. We all know that these continents are not stationary. They are not stable. They are floating, rather they are moving. Now this movement is possible only because they are on this layer of asthenosphere. If you can see that the continental crust as well as the oceanic crust. Here I would like to tell you that the earth is divided into 15 major plates, and all these plates are moving, and the reason is asthenosphere. Because this act as the heat generates from here, and this heat which is generated helps in movement of the plates which are lying here. So this is one important thing about the mantle layer. Now second important thing is we have done one layer, lithosphere. What is lithosphere? The earth, when we talk, is divided into three spheres: lithosphere, atmosphere, hydrosphere, and if we include the living components, we call it biosphere. Now what is this lithosphere? The crust, upper part of crust, and this part which is not semi-molten, this part of the crust, mantle, which is below the crust, which is still brittle in nature, this part combiningly forms your lithosphere. I hope I am clear that lithosphere consists of upper part of mantle including the upper part of the crust, that is 100 kilometers. Clear about lithosphere, that lithosphere is made up of which two layers? It can be an important question regarding MCQs. Next, as we go down the mantle layer, it is again solid in nature. And slowly and gradually you will find the density of minerals or the elements increases as we go down. Next, below the mantle layer we have core. Now core, all of you know, is divided into two categories: the outer core and the inner core. Now what is most important regarding this inner core and outer core, I would like to tell you that when you will write about the core, you should write that the outer core is in liquid form, whereas your inner core is in solid. What is the reason behind the state of matter? Here the temperature is high, so rocks are in molten state, and your core is basically made up of two elements. One is nickel and the other one is iron. You will also find the word NIFE in your book, that core is made up of knife because nickel, Ni, and ferrum from iron. So your outer core is in liquid form because the temperature is high, and the iron which is present there is in molten state. But the inner core also, which also contains iron, is in solid form because any element or any matter will be in solid or liquid, or it will be in gaseous form, is determined by temperature as well as pressure. Though the temperature is extremely high, if we reach here, the temperature is 5000 to 6000 degrees Celsius, but the extreme pressure increases the melting point, and that's why we find, because of increased pressure, The iron which is present in the inner core cannot turn into a liquid, rather it remains into a solid form. So I hope it's clear one important thing regarding the boundaries between crust and mantle. This crust and mantle are divided by, if I talk about if this is the crust and this is the mantle, how do we know suddenly the structure is changed into a layered structure? Because we have also studied about the earthquake when we were doing volcanic eruption. And when an earthquake takes place, we have learned that they generate energy. This energy generates waves like S waves, P waves and surface waves. Now when these waves starts moving in different direction, they change their velocity with change in the elements. So we find that there is a change in the elements between crust and mantle because their speed changes. This line of change or the transition zone is known as Moho discontinuity. It means there is no continuation between crust and mantle. The elements which are present here are not similar to the elements which are present here. So there is a discontinuity, and it was first discovered in 1909 by Mohor Visick, a scientist. So they named it Moho discontinuity. In the same way, the mantle and the core. We know the condition of mantle and core is different because it is liquid and it is solid. When we were studying earthquake waves, in one place we came to know that S waves can travel only through solid. So it means as soon as if there is a layer which is liquid, the S waves cannot be recorded. So there is again a discontinuity between mantle and core. This discontinuity is known as Gutenberg discontinuity. So clear what is the meaning of the word discontinuity and how earthquake waves help us or volcanic eruption help us to know the earth. So this was all about regarding the structure of the earth. I'll be giving you a worksheet along with this so that you can practice a diagram with proper labeling. Thank you.